Hello. So I asked this colleague of mine if they did anything fun on the weekend, and they go like, well, it was raining, so, I just stayed home and played with React. And I just stared at them thinking, how do you even play with React? Okay, they see my confusion, and they go like, well, I just built a bunch of web forms. What about you? So I told them about this video game in Elm, the programming language I've been working on, and they're like, this is so cool. I wish I was smart enough to build a video game. And this is where I get confused. I've had this conversation more than once when experienced, great developers tried to convince me that they were somehow not good enough to write a video game. So at first, I had this idea for the book. But then, A, this is mean, and B, everyone's idea of fun is different. So that said, if you're in this room and you have some interest in video games, I want you to know that you can build a video game, and it's also a great way to learn a new programming language. Oh, this is where you say, programming languages? I thought you were going to talk about video games. Yeah, but if you are a busy professional, like working on a game just for the sake of it can be hard to justify. However, if you combine it with learning about new tech, suddenly it's fun exercise and not another time-consuming project. And I like to think about learning new programming languages as traveling. You don't have to travel, and obviously you don't have to immigrate, but you might learn something by exposing yourself to different cultures. And I might be pushing this metaphor a little too far, but you tend to pick up really weird food habits while you travel. And don't take my word on this. Just read these made up, but perfectly plausible testimonials instead. Well, seriously though, there are so many exciting new languages these days. Elm, Clojure, Rust, pick one, you won't be disappointed. So back to video games. So a video game is not that different from your typical React app. You typically update state, process user inputs, and then update the view. But you also get to decide on things like how many times you can ask a friendly NPC for directions before she decides to murder you. Or fix bugs like, sleeping on a melting iceberg results in waking up as a demon. How do you even get that? But and this makes all the difference. And suddenly it doesn't feel like work anymore. And this is how, in this environment, learning comes naturally. And worst case scenario, you end up with a canvas full with randomly textured polygons. And if that's the case, remember this 1923 painting by Kandinsky. It's titled, Trying WebGL for the First Time. Okay, so building a video game might sound like a daunting first project. True, but you do need to build something non-trivial to get a good sense of the language. And it's not that bad. Learn how to write Hello World. Okay, you're ready to write a text adventure. Figured out a way to put a pixel on the screen. Okay, the sky's the limit. So, yeah, and one of the reasons I'm giving this talk in the first place is that not enough people are writing video games in new programming languages. And there's something in it for you too. A video game is a great way to draw attention from the community. In general, even a broken one is more exciting than a web form. Okay, so assume I convinced you. Where did you start? People seem to have one of these two problems. Either I don't have ideas or my ideas are way too ambitious. And I say, oh, forget your ideas and copy an existing game. Think of it like making a cover version of your favorite song. There's so many to pick from. Just don't start with an open world RPG. But yay, text adventures, card games, puzzles. I'm Russian, so I usually go with Tetris. But you don't have to. And there are even simpler choices. And you can also make a tribute to your favorite AAA title. For example, I built this Maze Escape game based on a single panel in The Witness. And if you like Skyrim, you can release the lockpick in minigame as a standalone challenge. And if you digress along the way, well, just go with it. Finally, some advice. Rule 1, focus on one core mechanic. Focus on one core mechanic. If you're excited about those procedurally generated puzzles, build them first. Don't try to, don't spend your time on the main menu. 2, start with the simplest rendering method. Text first, or in the browser, go from DOM to Canvas to WebGL. Don't bite too much at once. 3, render early. Don't try to write an engine. Put something on the screen, make change, repeat. It will keep things motivating. 4, cut corners. If you don't know how something should work, just fake it. This is not your job. Your job here is rule 5, have a lot of fun. So have a lot of fun, build something, and let me know what you build. Thank you.
I'm Scott Fraser. This is Jason. We're from ECRI Institute out in Plymouth Meeting. And we're going to tell you about a cool project we did. Basically, real quick, for some context, we're a nonprofit. We're 50 years old. Most of the hospitals in the U.S. use us. We're also a registered charity. We have a lot of money, but we have to be careful with it. So when we needed lots of hardware for our dev and stage environments, we needed lots of compute. I wanted to spend most of it on solid-state storage, so we came up with this crazy project that we're going to tell you about.
Crazy.
Yeah, and the reason is we're growing very fast, and more of our content's being delivered online as opposed to print. So the plan was to find a way to get more cheap powers. How?
Laptops. Wow. 45 or more laptops we found being recycled. Why don't we use that for our cluster?
Now, where are we going to put the laptops? We need some racks.
We actually, this is real, we're using it. One of our colleagues welded this together. Those are bookends. We couldn't find anything other than bookends and welding it to a server shelf. We were using them.
It's beautiful.
Really. And crazy.
Next plan, take them to the server room.
Here we are wiring it up. This is our colleague Dave. I'm not sure if he's congratulating us or thinking I'm crazy, but we're wiring this up together.
Turn them on.
And it's working. It's running. One interesting thing, pointing out, we removed the batteries. Power supplies on the second shelf because of cooling. They get hot.
All right, Jason, tell me, so we work in healthcare. Security is a big deal. We have a lot of very sensitive information. So tell me a little bit about some of the challenges related to security.
So we have SSL, TLS everywhere. We require lots of crypto. It required us, one piece of software we had to write was a key encryption server. We had to fork a SUSE project and added LVM and Lux support to that. We will be releasing that on GitHub soon. But yeah, that was extremely difficult. And along the way, crazy, because every step here, Scott was saying, can we really do this? And I would say, yeah, I think we can. I think we can.
What distro Linux did you use?
Well, we're using CentOS, but Atomic OS to be Fedora Core OS, and it was the most stable. Now, I know a lot of people here are probably thinking, why don't you use Ubuntu or some other, upstream Fedora? Well, we found that CentOS was the most stable.
And how did you make ease of deployment, like just dropping in new laptops as easy as possible?
We tried to pixie boot and Ansible bootstrap as much as we can.
And then we showed you all how we did the racking. We basically built our own. And the power supplies we talked to you about. We removed the batteries.
Or start a fire.
Tell me about networking.
Yeah, we had to, that was probably the biggest challenge, second to the key encryption server. The networking, as anyone knows, putting Linux on a laptop is a very hard thing to do and have it work right, especially if you want to run a Kubernetes cluster on it. With the networking, we had to do some fiddling with the drivers and configuration. I have done network driver development, so it wasn't so bad, but that was a challenge for sure. And if you're going to do this, that's probably going to be the one thing that may not work smoothly for you.
All right. So what environments did we use this cluster for?
It's rolling out for our development and test environment. Everyone who's doing deploying and dev and test,
right.
deploying there.
What version of Kubernetes are we using?
OpenShift 3.11, which I believe is Kubernetes 1.10.
All right, and what have we done with storage?
Yeah, we're using Gluster, Ceph, host local, nothing fancy there.
And so far, recycled laptops, how much do you have in your closet ready, and what's the total capacity?
This was the crazy thing. So when Scott was like, we need power, and I saw laptops, I looked at them. They were all Intel Extreme CPUs with 32 gigs of RAM, which is a lot. So absolutely, and you can see, on the slide, 360 hyper-threaded cores. That's great. That's fantastic.
How many pods are running on the cluster right
Currently 300.
Okay. What do you think is going to happen with pod growth?
Double, maybe triple.
Can you describe the workload mix that we've been running on the cluster so far?
Currently running all of our CI jobs, deploying all of our applications, and pending data pipeline.
How's the performance been?
Faster than our virtualization production infrastructure.
Sad but true.
Much faster.
What's next?
Yeah, we're probably gonna do service mesh, Istio, maybe some multi-cloud and cluster integration.
Are we hiring?
Oh yeah, we're hiring. And if you want to do fun things, come to Eckerd.
So this is stability bit versioning. I'm Richard Feldman. This is going to be a very low-key talk. It's about a very small idea. And this is an observational versioning system in that I've observed it and I decided to give a name to it. All right, so this is Donald Knuth. A show of hands, who knows who this guy is? Yeah, so he's developed a lot of things in his career, one of which is that he's probably most known for is tech. So this is like a layout typesetting engine that is widely used in like academic papers. If you've ever read a computer science paper, chances are it was laid out in tech. So he like released it, released version 1, released version 2, released version 3. And starting with version 3, the version numbers got a little unusual. So after 3 came 3.1, then 3.14, and then 3.1.4. So they're approaching pi. And this is intentional. This is how they're going to be versioned from now until, as Knuth said, until the day he dies, at which point he has said he wants tech to be declared version pi and no longer release any more updates. From then on, as he put it, all bugs are features. So I thought this was really interesting. This is like this idea of like planned stability, like a really, really hardcore notion of stability. And he says, yeah, you know what? I strongly believe that an unchanging system has great value. Let us regard these systems as fixed points, which should give the same results 100 years from now that they produce today. Okay, that's what he said in 1990. Well, I guess time will tell if that ends up being true, but it's certainly an interesting idea. So I was thinking about this in the context of software releases that I do and that people I know do, right? So usually you're doing some sort of like bug fixes or maybe the interface expanded, like if this is a library or a framework or a language, or maybe the interface changed. And we kind of tend to say, okay, well, non-breaking changes are sort of like minor and patch versions, like when we fix bugs or we expand the interface. But if we change the interface, like if we take something away or if we change the types or change the names, that's going to be a breaking change. And there's a few different ways that we do version numbers. So we have like the old timestamp model of like Office, and also like cars do this, Office 2019, Windows 98, Windows the whole versioning thing. I mean, or just sequential, we just keep incrementing it, right? Like Toast 17, next one I think will be Toast 18, we can safely predict. And then sometimes we have this like sequence and compatibility. So like you have multiple version digits, and each of them mean different things in terms of backwards compatibility. Of course, a really popular one of these is semver. So in this Linux example, we have like the 2 is the major version number, that first one. So that's like if there's a breaking change, we're going to increment that. Then we have minor, which means like the interface expanded. And then patch, which means like we didn't change the interface at all. And then optionally, semver allows for like maybe like a label for like pre-release metadata. So like either another number, or maybe like a beta or an RC1 or something like that. So what's interesting about this is to think about these in terms of stability, right? So nothing in semver, or really any versioning system I've heard of, really talks about stability in the Knuth sense, like any kind of promise about what's going to happen in the future. So, at one end of the spectrum, you have like, okay, there's a new version. Anything could change, and like best case scenario, I'm going to bump the major version number if stuff changed in a breaking way. And then at the opposite end of the spectrum, you have Knuth saying no changes, no new versions ever. But in between, we have this idea of backwards compatibility, and sort of like, okay, we made a new release, we are intentionally making it backwards compatible. So this brings me to stability bit versioning, and this is the term that I've come up with for some projects that I've observed, where they basically treat, it's like semantic versioning, but the first digit is a bit, it's a 0 or a 1, and they never go above 1. Once they release 1.0, they say, you know what, that's it, no more breaking changes. From now on, we're going to be backwards compatible. So it's like semver, but the first digit can only be 0 or 1. 0 means we're going to allow breaking changes. So this is maybe like in the alpha or beta period. And then the 1 means no more breaking changes. From now on, we are backwards compatible. We are committed to that. So for example, here we have like a 0 bit is either 0 or 1. 0 meaning unstable, 1 meaning stable. If the first digit is 0, then the meaning of the second digit is like this is a non-breaking change. If it's a 0, then the first digit is a breaking change. So you can say like between 0.1.1 and 0.2.0, that's a breaking like alpha release. It's sort of like semver shifted over by 1. And then if it's a 1 in the first position, then it's like minor and patch, just like normal semver. So as an example, so this would be a non-breaking change, but it's saying this is an unstable interface. Like the first digit being 0 means, hey, this is unstable. We're going to make breaking changes. This is not going to be backwards compatible territory. We're not making any Knuth-like promises here. Whereas in this versioning scheme, the first digit is called a 1. That means that we are in stable mode. Like we're saying, yeah, you know what? From now on, we're not going to make backwards incompatible changes. So as far as I know, I don't know of anyone who has called this stability bit versioning, except for me in these few minutes. But it is something that I have observed in a few different contexts. Like, for example, Java. It seems pretty safe to assume that at this point they're not going to make backwards incompatible changes because it's been out for so long. Rust has made a pretty public commitment to this. Clojure creator Rich Hickey has been really adamant that he thinks that breaking changes are broken and a bad idea. And so I think it's interesting to sort of give this thing a name and see if people would like to commit to it using that name as a way of saying up front, hey, I'm not just following semver, I'm following stability bit versioning. So please consider this as something potentially interesting for your projects. Thanks.
Hi, my name is Bobby Wren. I'm a software engineer with Xfinity Home, and I'm also an avid bike rider and bike mechanic in the loosest sense. So I'm going to talk about a little bit of what I've learned about software engineering through trying to fix my bike. So basically, bikes and software are pretty similar. They're both complicated systems that require a lot of thought, a lot of development, a lot of fixing, right? So you have bugs in software. You also have bugs in bikes. Sometimes the brake cable doesn't work. Sometimes the tire's flat. So as an engineer, I am someone who uses software and uses bikes, but I'm also able to fix my own code and fix my own bikes. So in the time that I've spent in the bike shop, I've learned that bike mechanics are natural software engineers because they automatically do the next 3 principles that I'll talk about. First, unit testing. When you go into a bike shop and you're fixing things, you're naturally doing unit testing, right? So to the software engineers in the room, this is what fixing a bike is going to look like. First, let's write a test called test wheels move. That test only passes if the tire has air and rotation speed is greater than 0. So sure, it brakes at first, we do something, and then it passes, move on. Let's test that the seat fits, right? So test seat fit will only pass if seat is non-nil and also that your feet touch the ground. So that's pretty easy to understand. Here's an integration test called test brakes work. So to test it, we first call the function squeeze brakes and test that speed has become 0, but also collided with car is false, okay? And in the real world, you want to make sure that this test passes before you deploy to production, obviously. Okay, secondly, when I'm in the bike shop, I am very thankful for the concept of reusable components. So I'm trying to replace a gear, I'm trying to find a new nut that fits into the center spoke. I can just dig through this old box of parts and find the ones that have more or less the same fit. I mean, they have to fit pretty well, but they work in the same way, and I just pop it right in. As a software engineer, I find myself not doing reusable components sometimes. Like, it's easier to just write a piece of code that does exactly what I want to do and then deal with it later, right? But really, I would say instead of doing that, go out and find a framework that's already been done, because that way you're essentially not reinventing the wheel. Reusable components. And then the last thing, when you're in the bike shop, you really get to understand the 80-20 principle. You're going to spend 20% of your time fixing 80% of the problems. But if you want that last 20% of your bike to work really well, you're going to spend 80% of the time, right? So one example is I've got my wheel, right? The unit test pass. It spins, it has air. Great. That's 80% of what I need it to be. I can take it and write out right away. But if I want the wheel to be perfectly not warped and spins perfectly, I'm going to spend another 4 hours twisting each spoke. Here you're testing how the alignment of the edge works, right? I've spent 4 or 5 hours just doing that, and the wheel feels exactly the same. So sometimes you have to make that choice. Do I want to spend this time? Do I just ride home? Okay, so last thing. Spent a lot of time talking about how they're similar. Here are some wish lists. So when you're in the bike shop, wouldn't it be nice if there were breakpoints, right? You're riding along or you're fixing your bike and something breaks, something fails, but I have a break point, so it stops right before I fall forward over my handlebars. And then I can say, okay, why did that happen? Let me fix it, and I won't hurt myself. Wouldn't it be nice to have git stash? So I'm trying to fix my brake cable, and I accidentally snip it. Oh, shit, I have to get a new brake cable. No, let me stash it, and I'm back to the moment before it broke. So git stash in the bike shop. As a software engineer, I've got some code, it's not working. All I have to do is spray on some rust remover, come back in an hour, and it's efficient, and it's shiny, and it works really well, passes tests. So rust removal would be great. And then finally, a system like Craigslist, which, you know, in hindsight, it kind of exists. But there's a platform where I can buy and sell old projects that I no longer want to work on, or maybe someone else wants to take from me. So that would be great to have. So that's it. Thank you very much. And tune in next week for Cooking with Version Control.
So I've been running Cassandra and prod for a while. I've burned my hands and my teammates' hands, and they burned my hands. We hurt each other a lot with this thing because people put stuff in prod, don't know how Cassandra works, me included, and bad things happen, and then we learn. So this talk is about that. All right. So in Cassandra, you do not normalize anything ever, right? So coming from a SQL background, if you normalize, you're doing it wrong. It's almost universally true, so don't do it. Denormalize all the things all the time. And the reason you can do that is because disk is cheap, so just use the disk. All right, if you don't learn anything from this talk and you forget all of it, this is the one thing I want you to remember. CCM, Cassandra Cluster Manager. It's on GitHub. Look at it. So if you have a Cassandra deployment, a lot of times the documentation is not clear, you don't know what you're doing, Stack Overflow is not clear, there's very little information, but you have a feature that you need to do. How do you know you're doing the right thing? Cassandra Cluster Manager. What this thing does is it tweaks the memory settings and other settings for your Cassandra, so you could run a bunch of nodes locally, and you could try stuff. So the way you know that you're doing something wrong is if you look at the logs when you make requests, the queries against your Cassandra cluster, and you see the network traffic spike between the nodes, right? So try to do it with like, okay, here I'm hitting it by a key, which I know should be fast, or I'm doing this other query that I want to try to figure out. And if you see network traffic go nuts, you're doing it wrong, and it will break once you hit over a certain volume in prod. Do not find out about it in prod. Use Cassandra Cluster Manager so you don't have to wake up in the middle of the night because your nodes are no longer responding and your queries are all failing because it's saying it can't find a local quorum. Don't be that guy. This guy. Don't do that. All right. So a little bit about how Cassandra works. There's something known as a partition key. So the partition key is analogous to a primary key, but it's not a primary key. It's a different database, different problems that it's solving. Things are not the same. So, but this one is actually close. So partition key is kind of like your primary key in SQL, right? You use that key, you query by it, it's unique, you get your data back. All right? So Cassandra, right, so you don't, one more thing I should say, you do not go into a distributed world if you can help it. If your data fits on SQL and you don't have to go there, don't go there. You're just creating problems for yourself. So let's say you have a bunch of Cassandra rings, right? Your data, your key gets hashed and ends up in one of those rings. So when you query by it, your system internally hashes it and finds the right ring where your data resides, so you get it from there, right? Okay, so you could have multiple keys when you design your Cassandra cluster. The first key is the partition key. The second key is the clustering key. So you have your primary key, right? But the secondary key is the sort. So it's kind of like an order by in SQL, right? So you can have multiple of these keys. So your data, you could find it by key 1, right? Or you could find multiple data by that has, well, no, just you find your data by key 1, and it's sorted by key 2. So clustering key equals sort. All right, so in this second table, So you can have compound keys, right? So your key K1 and K2, right? Those two keys make up your primary key together. So they hash together, they go to a node, you can get data from that node. Your sorts are like K clustering 1, K clustering 2, K clustering 3. Those are like your order bys, right? So you can set, so it's order by column, K cluster 1, K cluster 2, K cluster 3, right? So you can do that, you can get multiple entries back and you can figure out the sort order. All right, wide rows. So Cassandra is not like SQL, right? Most SQL tables that I've seen don't have more than, let's say, 7 columns. The limits for Cassandra are quite beyond that, right? So all data can fit on, so you have to just have about enough data to fit on a disk on one machine at one time for one column, or for one row, right? So you can have a 2 gigabyte column and have 2 billion rows in that one, 2 gigabyte row with 2 billion columns in that one row, right? So in practice, I've never seen 2 billion columns in one row because that's crazy, but you could have hundreds, right? You can have hundreds of rows. They're sparse, so they don't all have to be populated. So you can have 1,000 different permutations, and you could only use, let's say, 200 of these columns, right? It doesn't take more space if there's no data in that column. So you can model around that. I don't have time to get into that, but that's a feature you should be using if you're not using it now. Wide rows are good. All right, immutable data. So in SQL and other databases that only work on one machine, usually your data shouldn't be immutable because you don't have space to store all of it, right? Imagine all your customer record changing, right? And every time you change it, you just replace it, right? Because there's a constraint. In Cassandra, it's okay. You've got a ton of space. Chances are if you're using it for the right reasons, you're not doing it wrong. You have a bunch of nodes. They have terabytes of space. You're fine. So you can afford to have your data be immutable, and it will work better. You're not going to have read repairs and all that other crap. All right. So the not so great, right? If you have a fake customer data, right, with 100 columns, and you have a customer ID, right, and then there's some foobar, blah, 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 right? So that's not so good because in order to update that, you have to go get 100 and put some data on there. So you keep overwriting the customer ID 100, right? Just kind of like SQL. The better version is put a timestamp, or better yet, time UUID type. So if you have two events that happen in the same millisecond, they don't overwrite each other. But for clarity, I put in a timestamp here, right? So you can have your customer ID, something happened, you put in the same customer ID with a timestamp and updated data. Same thing for customer 200 and 300, right? So you could keep track of counters this way. So you could kind of treat it as an audit log. This makes things a lot easier to debug because you can go back in time and see how a customer looked like. Or if you're, let's say, dealing with something that you need to add up, like let's say finances, which you probably shouldn't do in Cassandra, but let's say you did, right? You can then scan the ID and figure out all the debits and credits, right, and add them up. The only problem with that is if something gets too big, right, like you don't want to scan, a million entries since the beginning of your account being open at a bank, right? You don't want 10 years of that. So you could checkpoint it. Like you could have a job at night that runs every couple of weeks, right? And it checkpoints, it adds everything up and adds a record, right? So you'd know that your logic would know it doesn't have to go and scan the entire range if that's a problem you think you'll have. All right, that's it. Thank you.
All right. Hi, I'm Roderick Trout. I'm an engineering director at Comcast, and I really wish I didn't have to give this talk. I'm guessing most of you in this room either have or one day you're going to make an SDK. You're going to make some code to share with other developers. But how many of you have heard of developer experience design? Well, very few. I expected more. That's why I'm giving this talk. Okay, so developer experience design, or DX, is kind of like user experience design, or UX. We've all heard of UX, right? So UX is all about making products easy or pleasing to use. But when your services or tools or your product is something for developers, then your interface is your API. It's your SDK, right? And your users are developers. And it makes sense to understand how they work and to optimize for their experience. So I made this SDK rating scale about a year ago. I've done a year of a lot of iOS and Android SDK integrations. And I can't tell you, too many of them were absolutely frustrating and confusing. We're talking 1- and 2-star experiences out there in the industry. And worst of all, I wasn't always confident in the end that the SDK was going to work properly and not crash my app. Now, full disclosure, I don't just use this to go out and judge other people's SDKs. I actually did use this on my own SDK one time, and I gave us a 3-star experience. I did fix it after that, but it's a useful tool. There's a lot that goes into providing a good developer experience, but since I only have probably 3 minutes left, I'm just going to focus on 3 areas. The most important thing that an SDK needs to do is just something useful, right? And to be useful enough to share, it needs to fit more than just your specific use cases and your specific app architecture. There's a spectrum between being too specific and too generic, and you want to be in the middle. SDKs are too specific when they make too many assumptions around how the host app is structured and the dependencies that you have. So why would an analytics library depend on a specific HTTP client, right? It makes no sense. They have nothing to do with each other. Sometimes there's a legit reason to have a specific dependency as an SDK, like when you're offering an extension of another library, like Rescue Scheduler extends Rescue. That makes sense, right? You can also be too generic with your solutions and water down your library's features so much that it's confusing to use, not to mention a nightmare to test and maintain. It's okay to draw a line and say, we don't do that, right? So Makito, for example, doesn't provide mocking for static methods, and they don't think that you should need that. And that's great. If you disagree, you can use PowerMock. One obvious way when SDKs have gone too far and trying to solve every problem in every use case and be too generic is when they take a dozen init parameters or several dozen configuration options. I don't want to have to read several pages of documentation to learn how to start your SDK, right? If I wanted to do that much work, I would write the library myself. A related DX crime, in my opinion, is the Mega SDK. You see this a lot from SaaS companies, and they want you to integrate their enormous SDK that does everything, even if you only want to use one feature. Don't do that. You're making my app fat. No matter how great your code is, though, and how perfectly scoped your features are and how well it works, it doesn't matter if no one knows how to use it. If your library is a repo with just your code and an empty README, I'm going to talk to you right now, okay? It's not that hard. Make a README, explain what your SDK does and how to integrate it. Provide some code that I can copy and paste into my app. And even better, provide a sample app that I can run to see how it works and see if I actually want to use it. Additionally, and this is one that I rarely see, but provide a way for your SDK users to confirm that everything is working properly. What should they test? How? Maybe you have some debug logging that prints out to confirm that the data is flowing in the right direction, or maybe you just document some manual testing steps to complete after the integration. So if you build a great library and you have excellent onboarding and integration instructions, it doesn't end there. I can't think of a single SDK that never needs to be updated. There are always going to be bugs or new features that you want to add, or OS version updates, or any number of reasons why at least a minimum amount of maintenance is going to be required. For open source software, that's on us, the community, right? You got to care for the libraries you love. But if you're an open source maintainer and you can't maintain your library, you don't owe us anything, but put some documentation in there for how to take up builds and maintenance so that anyone else can follow in your footsteps. For commercial APIs and SDKs, though, I expect your library to keep working for me as long as I'm paying you money. And I expect you to be releasing on a regular cadence and notifying me if you identify issues or risks that might impact me. All that hard work that you put in to creating a frictionless path to success with the initial integration, it needs to be repeated for all the features that you're adding in the future. In the rush to get features to market, developers often lag in updating documentation and sample apps. This is really important, folks. If it's not documented, it might as well not exist. We put SDKs out there because we want people to use them. Don't undermine that mission by providing a poor developer experience. Let's all stop making SDKs that suck.
So I'll start with a show of hands. How many people do logging from their apps? Okay, almost everyone. Well, that's a good start because really, you have to do logging to do effective logging. And kind of the key thing that I realized is that there are only two reasons that you would ever want to do logging. The first is you're in a regulated environment. In that case, you're told what to log, where to log it, and there's nothing about effectiveness there. You just have to do it. The other case is for yourself, where you're coming back minutes, hours, months later to find a problem. And the only thing you have are the log messages. Okay, so trick number one is use the right log level. And I kind of never really thought too much about this until I was working with some people transitioning from JavaScript to back-end development who said, oh yeah, we just use console.log. Now we've got all these choices. I've also run into cases where people do form field validation writing error logs, which completely loses real errors. I've been in places where production turns off debug logs to save disk space, which is great until your customer says, hey, why didn't my transaction go through? And you go, I don't know. So again, picking the right log level increases signal to noise ratio, helps you debug your problems. Okay, this was kind of a new slide for this, based on what happened to Facebook recently. Be really, really careful. I have logged a credit card number. Thankfully, it didn't go to production. Passwords. You may think, I'm just logging the username from my login form. You'd be amazed at how many people type their passwords into username fields. So whenever you write a log message, think about it. And if you're using Scala case classes, you probably want to take a lot of care. All right, number 3, and this is a big revelation for me, is use JSON. All right, I showed you some basic text logging in the first slide. And text logging is great if you're running a single application on a single node. Here's where we get into the distributed world. You need additional information. You need to know your process ID. You need to know what host name you're running on. You may have a dozen things you want to put into the log. And you can do it in text logs, and you can get really creative with text logs, but JSON is an extensible format that's available everywhere. And the other key thing is that JSON is what Elasticsearch wants, and that takes me to trick number 4 of the 3 tricks, which is use a search engine to do your log aggregation. It's really nice if you're in a system with, say, 3 or 4 microservices, some of which are running asynchronously, that you can go in and, oh, here's an error in my web app. Let's trace this interaction all the way through, from the web app through all of the back-end services, and see if we can figure out what happened with it. So, highly recommend this. So, to recap, use the right log level, careful what you log, use JSON so that you can use a search engine, and always look out for off by 1 errors.
Hi everyone, my name's Andrew, and I'm going to tell you about the CSI, the Container Storage Interface. I work at Linode, and this talk is about taking your storage to cloud-native land, where everyone lives. So the CSI is a Container Storage Interface. It's an RPC-based plugin API specification for container storage management. So now our stateless workloads can be stateful if we want to store logs, for example. Here's how it works. A container orchestrator, which could be Kubernetes, could be Mesos, could be Nomad, it calls remote procedures via gRPC to CSI servers. And these servers are just binaries that run in the cluster. So we could call these drivers, and they implement 3 services: identity, controller, and node. The identity service tells the container orchestrator the name of the plugin, what it can do in terms of storage, and its current status. The controller service performs operations that are global to the container orchestrator or external to the container orchestrator. Sometimes you don't have anything external, and CSI is very flexible in that regard. The node service performs operations that are local to a machine and a container managed by the container orchestrator. So it's common for all 3 of these services to be compiled into the same container image, and then you deploy this in a centralized or distributed fashion. In Kubernetes, it's a distributed fashion. The CSI gRPC server is running on every node of the cluster. All APIs are designed to be idempotent. This is very important. So when you're designing an API, you don't want side effects to happen if you make the same API call with the same parameters. So in CSI, the gRPC call for create is create A. So it's not create, it's create A. This means you can keep saying create A, create A, create A, and it'll only create A. It won't create B, C, D, E, F, and we call these orphans. So there's no orphans in CSI. And also duplicate calls to delete will not delete things that you don't expect to be deleted because you're saying delete A. It won't delete B or C or D. And the API was designed to be simple and compatible with many systems, so both network attached storage and local storage, like LVM, block storage and object storage if you use Fuse, pre-formatted file systems and raw block devices, pre-provisioned storage and dynamically provisioned storage, single writer storage and multiple writer storage. And you might be thinking, well, it's got to be so complex to do all these things. No, it's very simple. This is the whole API. So you create a volume, you publish the volume, you node publish the volume, and then you can go backwards. You can unpublish the volume, you can uncontroller publish the volume, and then delete the volume. Why do we need these two different ideas of publish? Well, the first publish is to kind of like place the disk onto the node, and the second notion of publish is to like allow a bind mount to happen. So it's like maybe when it's node ready, it doesn't have a file system, and then when it's published, it has a file system. Here's some examples. Linode, we have a block storage product, and we have a CSI driver for that product. So Kubernetes, Mesos, Nomad, bada bing, bada boom. Google, Amazon, Azure, VMware, DigitalOcean, they all have their own CSI drivers. There are vendors like Portworx that implement their own CSI drivers, and if you're a storage vendor or you have some proprietary storage system or you use NFS, you can use this NFS CSI driver, it's not very good, or you can write your own. These things are like 1,000 lines. It's like really not that hard. And the current version of the spec is 1.1. It was released a little over a month ago, a little more than a month ago now. And the new features are expansion, cloning, and topology support. Topology means that you really want the disk to be close to the container. For further information, you can hit up the CSI team on Kubernetes Slack. They're very responsive, and you can tell them features that you want, and they'll say no, and then maybe they'll say yes later. So thanks for attending. My name's Andrew. I work at Linode, linode.com/Kubernetes. You can hit me on Twitter, WK3AS on Twitter, and we have a channel on Kubernetes Slack, #Linode. Thanks, Chariot Solutions, for this amazing conference.
All right, Chrome DevTools, features you didn't know existed. So we probably all spend at least a little bit of time in Chrome DevTools trying to figure out what's going on with your DOM or a web page, anything like that. I'm Jonathan Belcher. I also go by JB. I'm a JavaScript Electro Wizard at Automatic. We get to choose our own titles, so that's why not? So if you spend any time in the Chrome DevTools, you'll see every time you get a new version of Chrome, every time you hit Command-Option-I, inspect, it comes up on this What's New tab. And I'm always, the first thing I do is I do a little, quick, I look through it, and then I usually just close it, which you can do right here. But if you are tired of seeing it, you can also go into your options. And where are my options? Settings. And then inside of here, it's got the show what's new after each update. So you just uncheck that, and then it's not going to show it to you again. If you do want to look at it, but you can also take you can open up the drawer, which is Command-Shift-P, and it opens up a command drawer just like you would get with Atom or Sublime or other editors, and you can type in what's new. So you can say show what's new, and it'll show it. Or you can say what's new, and you can also, it doesn't change it for you. So if I want to get it back, I can say what's new, and it'll show it. It'll show it again. So now that we have access to our drawer, and again, that's Command-Shift-P. I don't know what it is on Windows and Linux, but I want to take a screenshot of the entire page. What I used to do is add an extension to Chrome, and then somebody would add injection to that extension, and then I would get really upset, and then I would delete the extension and find a new one, and then they would inject ads into that extension. Thankfully, Chrome has this taken care of, and so we can do screenshot. And so I'm going to capture full-size screenshot. I click that button, and it takes the screenshot and gives me a screenshot, and it's the whole page, just not above the fold, right? So that's pretty fantastic. Yeah, I mean, all right, I'm done, that's it. Yeah, thank the Chrome DevTools team for that, not me. Okay, so contrast accessibility with the color picker. The color picker in Chrome is amazing, and it's just getting better and better and better. So if you hit inspect, and then you click on any one of your colors, and you open up the contrast. How big am I? Maybe I'll make it a little bigger here. So if you hit the contrast ratio, it'll show you some guides to tell you what a good, so if I'm up here, obviously that's really bad contrast, and if you're below the two lines, you're good for accessibility standards on the contrast. But if you're in the middle, you meet some accessibility standards, just not all of them. So if you can, stay below both lines, and that's fantastic. As we can see here on this color, we may want to take a look at this because we only meet the AA standards, not the AAA standards. We probably could just bring it down a little bit and add more contrast to make it easier to read. And I'm talking about the contrast between the font color and the background. Just me. So next is drag and drop DOM. So if I take a look at if I'm messing around and I want to see what a web page looks like when DOM is in a couple different places, I don't have to write up that code or move things around in the code. I can just grab this DOM. So this is Jetpack, and we're going to move it down 5 or 6 spots. It moves Jetpack all the way down here. So I just grab that DOM, move it around, and you can even take your H2, and I can move that H2 down. And that didn't work because that was the wrong H2. Let's say I want to move the header after all of this. I can just drag and drop that down, and it'll move the header down below. So that's pretty fun. Next is a $0 DOM selection. So if I'm inside of my DOM again, so I'm going to hit inspect, and I'm going to select this Jetpack div, and I'm going to say $0, hit enter, and it's going to plop that DOM element right into my my console. So then I can do manipulation on that, and I can say $0.class list. If I want to see the class list, gives me the DOM token list, so I see that I have haiku. So if I do that same thing, .add, and I'm going to add in foo. It added the class foo into Jetpack. But let's say that I want to do something like, let's select, so I'm going to add a new style real quick. Yeah, I'll just do this. So if I grab the P element and I do $0.color, style.color, equals red, and I need quotes here. So I changed my color of my paragraph tag to red. Next, changes. I didn't really have a website that. So if I change this color, if I turn that on, if I turn off this color, and I go to the Changes tab, and you can get to the Changes tab via your Command-Shift-P changes, or you can get it through this little ellipsis here and click Changes. It's going to show you changes that you've made to JavaScript files and CSS files. But since all of this CSS and JavaScript is all minified like it should be in production, I had to find a really old website. I did it 12 years ago, guys. Give me some credit. It was 12 years ago. So this is unminified CSS. And so if I start changing things here, you can see that it diffs what you've made changes to. So when you go through and you're making a bunch of changes in the Elements panel, and then you forget what you actually did, and then you hit refresh by accident, and all of those changes go away, and you're really upset, go to the Changes panel and see what you did, and then maybe if you need to copy things out. The same can be said for the Sources panel. So if you make changes to a JavaScript file, you can see those changes in real time in the Changes tab. Okay, let's get rid of that. I can't look at it anymore. The next is paint flashing rectangles. This is really good to have when you are looking at DOM and you're trying to see what's causing repaints. So I'm going to open this, and I'm going to Command-Shift-P, and I'm going to say rectangles, show paint flashing rectangles. And as you can see, when I change the size of the viewport, everything repainted because it has to repaint. But if I just scroll, we can see that the only repaints are happening over here. You can see here, as I'm hovering over things, it repaints the entire graph. So that's fantastic. But what if I have something that I think is repainting a lot? And you can see here, this is doing a lot of repainting. And I don't know if you can tell, but it's repainting all of this as I change the image over on the right. So obviously something's wrong, and it's causing a repaint over there, which you might not necessarily want. Dark theme. So I like to have everything in dark theme. Again, you could do this in settings, but I use my drawer a lot, and I want to say dark theme, and I can switch to dark theme, and now I have my dark theme. So it matches my editor. Okay. One thing I'm always surprised to see when I talk to people, they're like, how did you clear your console? And it's just like your terminal. If you hit Command K, it deletes everything out of your terminal. So if I have, things fill up in there quick. So if you just hit Command K, it'll clear it for you. Pretty print. Again, if you're in your Sources panel, and I talked about all that minification, the little flower braces down here, if you click those, then it opens everything up for you, and you can actually see what's going on. This is especially useful when you click a JavaScript error, and then it takes you over to your Webpack, thing, and you can't see anything's going on. Unminified, pretty printed Webpack is still tough to read, but it's a lot more easier to read than if it's just been minified down to like 5 lines. Still good in time? Okay, screenshot a single. All right, so if I want to do a single element, so I want to just grab this one haiku, and I hit Command-Shift-P, and I hit screenshot, and I'm going to capture node screenshot. It captured the one node. Now, this is not particularly useful unless you're using margins and margins properly, because as you can see here, it cuts things off. So it's usually just better if you do an OS screenshot if you're trying to grab one particular node. Cookies are now editable. This happened about a year ago, and I didn't realize until I went over and I was trying to set a cookie, so I was having to delete the cookie, re-add the cookie, and because you didn't used to be able to change the value of a cookie. But now, if I want to change the value of something like the country code, I can change this from US to UK. And that will actually change the value of the cookie for that particular website. It doesn't always take. If you can see when I refresh, if I refresh, it will add Oh, it was adding the country code back. Sometimes if your website is adding those cookies and the values don't match, it'll add the thing back. But sometimes it's really useful if you're gating based on cookies or something like that. And then lastly is the console levels. So somebody else talked about info warnings and errors. You can also flag the verbose. If you click verbose right there, what it'll do is it'll tell you when you're doing things that you shouldn't be doing. Like, so this is a violation right here. DOM content loaded handler took 159, let's go with the 504 milliseconds, because that's a lot. And as we can see here, that on DOM content loaded, we're doing a lot of things that we probably shouldn't be doing in DOM content loaded, and we should put those in a request animation frame or do something else to take that off the main thread so that the rest of the page can load up and we're not blocking the main build, unless it absolutely has to happen in DOM content loaded. And that's it. There's lots and lots and lots and lots more that you don't know about Chrome DevTools. So go online, watch some videos, because there's so much awesome stuff that it does.